A joint pavement evaluation has been undertaken by the Indiana Department of Transportation, the Federal Highway Administration, and Keystone Engineering and Indianapolis Corporation. This pavement evaluation will consist of dry milling 3 slots in the pavement within each wheel path, cleaning the slots, placement of an epoxy-coated number 10 rebar, and backfilling the slots with a high-strength, rapid-setting mortar. This video will briefly illustrate the series of operations which were necessary to properly install these retrofitted load transfer devices across random transverse pavement cracks which occur between the 40-foot joints. This evaluation is located at Interstate 465 and Interstate 70 on the east side of Indianapolis. The pavement evaluation was conducted on the I-70 ramp from westbound I-70 to southbound I-465. The pavement was a 10-inch thick, reinforced concrete pavement with 40-foot joint spacings. The first operation was the simultaneous dry milling of the 3 slots in the wheel path. These slots were milled to a depth of 5 1/2 inches, approximately 2 1/4 inches wide, and were centered over the pavement cracks to achieve a 24-inch long slot at the bottom. The milling head was designed and operated by Keystone Engineering. The rotomill plunges to a depth of 5 1/2 inches, advances approximately 18 inches, and then is withdrawn from the slots. The tracked milling machine then advances to the next location. The second operation involves cleaning of the milled slots. Hand picks and shovels are used to remove the bulk of the milling debris. A front-end loader is used to collect and transfer the debris to a dump truck. Since this is a dry milling process, an air lance is used to blow the fine dust and other remaining debris out of and away from the slots. This leaves very clean slots which require no further surface preparation. Once the slots are clean, the backfilling of the slots begins by placement of a small amount of high-strength mortar in the bottom of the dry slots. This is followed by the consolidation of the mortar. The number 10 epoxy-coated rebars are placed and driven to the bottom of the slot. The remainder of the slot is then filled with high-strength, rapid-setting mortar, consolidated with a handheld vibrator, and finished at the pavement elevation with a trowel. This process was continued for the length of the ramp. In an 8-hour day, the milling machine was able to cut over 330 slots. Traffic was maintained in the adjacent lane to minimize any inconvenience to the motoring public. Curing compound was applied on the surface of the mortar patches after they had set sufficiently. This work was accomplished by the coordination of the Division of Materials and Tests, the Greenfield District's Indianapolis Subdistrict, and Keystone Engineering. The intent of these installations are to establish load transfer across the pavement crack to avoid pavement faulting in the future, restrain the crack from future lateral movement, and allow the retrofitted load transfer system at the crack to function as a hinge. Thus, all future pavement expansion and contraction will occur at the pavement joints where epoxy-coated dowel bars are in place. Field monitoring of the pavement performance over the next 3 to 5 years should reveal if this pavement evaluation is successful. If successful, this pavement repair technique will give the pavement engineers another rehabilitation tool to extend the life of our Indiana pavements.